Hi everyone, today I represent you a new cloud-native geospatial database called the Geocube. It's a project under development by Airbus with the support of the CNES, and it started with the question, how to efficiently handle massive spatio-temporal data on distributed environments? The answer is the Geocube, taking advantage of a modified COG file format capable of storing multiple datasets in one file. Let's get into the detail. The core of the Geocube is a scalable service using GDAL as image processing library, a PostGIS database to index images that are stored in an object storage such as GCS, AWS, or local file system. In the ecosystem of the Geocube, the ingesters are responsible for the massive ingestion of images from any public, commercial, or private catalogs. The ingesters are capable of pre-process images using predefined or custom scripts and indexed the images in the Geocube. Finally, an API is available to search images, optimize the database, ingest new images, and deliver aligned time series for massive and parallel workflows in standard languages such as Python or Golang, and parallel computing libraries such as Dask. In a nutshell, the Geocube is a cloud-native geospatial database designed to be easily deployed for a variety of Earth observation projects. The Geocube is sensor agnostic. It can process any raster format readable by GDAL in native resolution and prediction. But it is also able to reprocess the data to be optimized for the project itself. The Geocube was designed to efficiently work with spatiotemporal data, delivering multimodal and aligned time series. It has the ability to reproject data on the fly, and it can use a special data format based on COG, optimized to deliver time series on the cloud. Finally, the Geocube is a scalable and distributed solution that can be hosted locally or on a distributed platform to answer multiple needs from commercial application to more local R&D services. But what makes the Geocube so efficient to deliver time series? Actually, the Geocube can refactor the data to store several images in an optimized version of the COG. The COG is already an optimized GeoTIFF for the cloud, thanks to its internal organizations in the file. The data is splitted into tiles, and the indexes are grouped together. The MultiDataset COG, the new COG, goes one step further. It interlaces the full resolution blocks of several COGs, enabling a fast access to the whole time series of a given block. As in the COG, this interlacing preserves sparsity. Overviews can be stored spatially, contiguously, or interlaced, depending on the use case. This MuCOG respects the GeoTIFF standard that makes it readable by GDAL. The MuCOG is not mandatory, but it gives very good performance when it comes to reading a time series on a cloud storage. The MuCOG minimizes the latency by drastically decreasing the number of calls to the storage, in blue in the graphic. It reduces bandwidth usage by decreasing the volume of data read, and it results in a reduction of cost with a lower computing requirement. With a MuCOG, you can retrieve a block of 100 images in less than a second, which is 10 to 20 times faster than with COGs. 5 minutes is too short to convince you of the capabilities of the Geocube, but the Geocube is an open source project designed to be easily adapted to various environments, and even though it's still under development, the source code is already available on the Airbus Geo GitHub, so I invite you to have a try, share your comments, and get involved in the development. Thanks for your attention.
Great. Well, thank you to Vincent for that. That's very interesting. I've always dealt with time series in COGs as separate files, so I'm going to go back and visit this and take a look. It seems very cool. It looks like some really big performance gains there.